This video is for the Module 12 opener. So the things that we are going to be working on today are identifying triangles based on their angles and finding the area of rectangles or parallelograms. So a few things we need to remember are what acute, right, and obtuse angles mean. So acute angles, I always think of as little cute ones. So it's a triangle and it has with all three angles have to be less than 90 degrees in order for it to be classified as an acute angle. So when all three of them are little cute angles, we call it an acute triangle. Then next we have the right angle, which we also know as 90 degrees. So when the triangle has one right angle that is 90 degrees, we call that a right triangle. If our right triangle, we can't have more than two or more than one. If we tried to make two right angles on a triangle, they wouldn't connect. So it can only possibly have one right angle and the other two are going to be acute. But we don't call it an acute triangle because to be acute, all three have to be less than 90. So when it is a right triangle, it has an angle that is 90 degrees. And our last type of angle is the obtuse angle. So obtuse angle is the triangle that has an angle larger than 90 degrees. So if I draw an obtuse angle here, so that is larger than 90 degrees. When I connect the other two sides, they're going to be acute angles. But again, an acute angle has to have all three acute. So let's look at some triangles and classify these based on their angles. So looking here, so we can see this angle is acute, but this makes a square on it. So this is a right triangle. Here we have acute, but this one is bigger than 90 degrees. So this is an obtuse angle. Here we have acute. All three are smaller than 90 degrees, so this is an acute triangle. Got acute. So again, an acute triangle. That word sounds funny when you say it a lot of times. Here we have acute. Oh, then we've got this big obtuse angle, so it doesn't even matter what this other one is. This is an obtuse angle. And our last one, we've got an acute one here, but we have this square straight up and down and across, makes that 90 degrees. So this is a right triangle. So remember acute, all three have to be less than 90 degrees. A right triangle makes that L-shaped square that you could draw, and obtuse is going to be bigger than 90 degrees. So 90 degrees is straight up and down, an obtuse angle is wider than that. Hey, we are also going to make sure we know how to find the area of a parallelogram. And a parallelogram, remember, just has four sides. Opposites are parallel to each other. So first, I want you to find out how many squares are inside this polygon. So I can go through and I can count them. So area is figuring out how many squares. So we want to go through and count those here. So here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So there are 24 squares that fit inside the area of that rectangle. Can you remember how we figured that out mathematically, though? There's a much easier way than drawing and counting all of the units. So when we find the area of this parallelogram, we take the length, how many units the length is, and we separate it into that many sections. So this has 1, 2, 3, 4, 5, 6, 7, 8 units across. And we separate it into how many units the width is, which is 3, and length times width. And we don't want to write LXW. That is going to look like LXW. and x is not a variable. So instead we just write it LW. When those variables are together, that means to multiply. So length times width, 8 times 3 equals the area of 24. But we would not just want to write 24. That's correct, but not quite the right answer. Since we are finding the squares inside of the polygons, the area has to be squared. We found two dimensions, length times width, so we square our answer. So if we don't know what it was, we can just write units squared. So this tells me when I see something that is units squared, that was finding the area of something. So make sure we get that labeled correctly. So let's go ahead and try each of these problems here. So first we're going to do 9 times 4, so length times width. 9 times 4 is 36, and then it's centimeters. And we did area, so 36 centimeters squared. Let's come down here. Length is 8. Width is 5. 8 times 5 is 40, and it's meters squared. So in here, there would be 8 units across, 5 this way, makes 40 squares inside of that. So let's come up here, and I notice that these little marks mean that they are all congruent or the same. So this is a square. So we know this side is 8.5. Squares are the same. So this side is also, the length is 8.5. So go ahead and do 8.5 times 8.5. So 8.5 times 8.5 is 72.25 inches squared. And now come and try length times width on this rectangle down here. So 7.6 times 3.2. And then we can see 2 decimal places, so don't forget to move your decimal. So 24.32 feet squared. And then our last one here, let's try 1.2 times 14.7. So go ahead and try that one. Move your decimal 2 places when you're done. That one is 17.64 yards squared. Okay, go ahead and complete your Module 12. Are you ready?